I think I'll get us started. Good afternoon, everybody. My name is Melanie Roberts, and I'm Executive Director of the Washington State Academy of Sciences. Thanks so much for joining us today. This is our fifth Growing with AI webinar, exploring how artificial intelligence can contribute to a resilient, secure, and economically viable future for agriculture in Washington State. Curious if anybody has watched all of the other webinars so far. I'd just be curious to see that through raised hands. Can you do that in your reaction? I see. Let's see. Yeah, raise hands, thumbs up if you've seen them all. If you have not seen them, you can go on our website. And this will be recorded, and you can see the rest of the webinars that we've had on our website at your leisure. But today is like I said, the last of five that is going to explore how AI can be applied after harvest to reduce food waste, increase food security, optimize supply chains, and hopefully maximize profit and safety of food. Thank you so much to today's speakers for your participation, and thanks to the Washington State Department of Agriculture for helping to support this webinar series. I also want to thank our planning committee members, some of whom are on video, and they're going to be monitoring your questions and comments and helping with the Q&A at the end. We also really want to hear from you. We couldn't have 100 people on the video, but we encourage you to go ahead and open your chat box at the bottom right now, and use it liberally. Share your ideas, your thoughts, your questions. There will be some people answering them during the webinar, and we'll, of course, get to more during Q&A. And yeah, don't be shy about using that. Let's see. With that, I think I'll go ahead and hand it over to our host for this webinar, WSAS member Scot Hulbert. Scot is a Regents professor and Cook Endowed Chair for Cropping Systems Pathology at the Washington State University, and he's also a member of our planning committee. So turn it over to you, Scot. Thank you.
Thanks, Melanie, and welcome everybody. As Melanie said, I'm Scot Hulbert, and I'll be moderating today. For the last 8 years, I've been the research director for WSU Connors College of Ag, Human, and Natural Resource Sciences. So we're kind of the research arm of ag in Washington. So my focus is trying to address the research needed to keep Washington's ag healthy. It's been a struggle the last couple of years. Uh, in 2024, we were 50th out of 50 of the states for profitability in agriculture. The numbers aren't out for 2025, but I think it's in 2024 it was actually a negative number. So the industry can't afford losses that can be prevented, and post-harvest losses are those losses that occur between harvest and when the delivery to the consumer. So the losses might be the farmer's problem if they're storing their product before sale, or it could be the processor, the packer, the transporter, the retailer. It could be everybody's problem. The losses might be to normal physiological conditions like ripening, or they could be physiological disorders. It could be some environmental cue that starts the wrong process, physiological process, like a bunch of grain that's thinks it's time to germinate, and that's really hard on cereal quality. But it could also be due to the wrong microbes that's infecting the produce, or even worse, if the microbes infecting the consumer cause a recall or something. So the question before us today is, how can AI help address these challenges? So we've got four great speakers who are each offer a different perspective on the topic today. The first one is Ines Hanrahan. Ines is the executive director of the Washington Tree Fruit Research Commission, and she'll give us an overview of the post-harvest landscape in Washington, key challenges, decision points, and where AI could make a difference. The next speaker is Juming Tang. He's the Frank Jungers Endowed Chair in the Department of Industrial and Systems Engineering at UW. And Juming will share cutting edge research on AI-driven innovation in food processing. Shyam Sablani's a professor of biological systems engineering at Wazoo, and he will describe how digital twins may serve as a useful tool for optimizing supply chains. And lastly, Claire Zoellner is the director of data science at iFoodDS. And Claire will bring an industry perspective on how AI and data science are being applied to improve traceability and food quality through the produce supply chain. So each speaker will introduce themselves better than that at the beginning of their presentations. And we'll in the first hour, we'll get through these four speakers, and then we'll have the last half hour to conversations and questions. So now let me turn it over to Ines to set the stage for the panel.
Bring up my slides. All right. Everything good? Good. Okay. So I used the title Smart Post-Harvest Systems to bridge biology, automation, and artificial intelligence, because I think ultimately this is what we're trying to achieve in this sector. And I think this is a good topic. But most of us are not post-harvest physiologists. So I'm going to give you the post-harvest physiology 101 in 30 seconds or less. So once fruit is harvested, you have to imagine it's still alive. It is breathing, it is releasing heat, it's losing moisture, it can get sick, and it can die. So typically, one way to look at it is like what we're trying to do post-harvest is we're trying to do something like we try and put everything in hibernation, just like frogs. So we try and have moisture usually high. We try and have the temperature as low as possible. And we're trying to slow down the breathing to a point where something is alive, but not quite dead yet, and where we can bring it back alive. So that's kind of basically post-harvest physiology 101. There's a lot of other things that are at play in the post-harvest arena, and that is first the big decision of how and when to harvest. And then once you manage that, you have to transport your product somewhere. Typically, there is some way where it gets stored. In some cases, it's very fast. For example, for cherry, it usually takes 48 hours for the storage, and then hopefully it's sold. But for apples, it can be up to 1 year. You have to somehow in the process also decide what kind of packaging to use and how you will ship your product to make sure that it actually arrives at the consumer in the right condition. But also you have to take market consideration into account. What does the market want? When is a good time to sell your product? So the first big thing that everybody has to do is like decide when is something ready. In the case of tree fruit, there is the decision to be made. Do I have enough pickers? What is the weather going to look like? Can I pick how much fruit can I pick? Can I pick everything at once, or do I have to pick just one by one? What's in general my quality? Do I have enough of a fresh market quality that I can pick? Those are some of the things a grower would look at. What they're using in terms to determine quality is something that is relatively old-fashioned. They're looking at sugars and acids and at firmness, and in this case, at starch. All of these things are destructive, and all of them are just very crude proxies to tell you what the piece of fruit is really like. So where we really need some help with AI is developing next generation maturity indices. We have some scientists working on this, but this is a big data project that will need a big community to get this done and to also get it done for a lot of commodities. But that ultimately would help us a lot to really know exactly where every piece of fruit is at the time of harvest, and ultimately maybe even before then. Then the next thing is once we manage to somehow get fruit into picked, then we still have the question of, well, what do we have? Most of the time, it is not known what the size profile is, except for some sort of an estimation. We don't know exactly what the quality is and the color. Ideally, we would like to know this before we have fruit in the bin, or even when we still have things on the tree, so that we can plan for the supply chain. For example, one company might want to has maybe a good order for bagged apples, but they only have to be a certain size. But it's hard to tell which one is which. Um, Now, another problem in the post-harvest field is decay management. And I linked a nice article that gives a good overview that also will be shared with you guys later, that describes this conundrum very well. It used to be relatively simple. When there was broad spectrum fungicides, it basically killed everything, and that was that. Now we have more sophisticated fungicides that's better, or maybe also even biological fungicides. But now we have to take biology into account, and typically there's hurdle approaches, and it added a lot of complexity. So again, this is another area where we would need some data science to help us really manage this correctly. Now, the next question usually is, how long can I store something? You see in this bin that I show you here, well, clearly the storage outcome is maybe not what we anticipated. Typically, I must say, even today, 30% of the fruit that is designed or designated for fresh market doesn't make it to fresh market on average. That is really high. There's a lot of energy and effort that goes into growing this, and then it doesn't make it to the fresh market. So there is a big opportunity here to lower this, which will also ultimately help growers and companies stay more efficient. Well, a whole nother story is cherries, because they don't store very long. So once you got them, you got to sell them and within a couple of days. And so that is basically then the whole process has to speed up exponentially. And really, there's very, very little margin for error. In terms of how cherries are packed, you have dump tanks, you have leaf eliminators, you have something like that's called a cluster cutter. You have sorting, hydrocooling, sizing, grading, filling boxes, and then modified atmosphere packaging. All of this has to somehow work together without damaging the fruit. Some of the new technology that is coming to the warehouses and where we think we want to go is to have automated defect sorting, where we do two things. We identify the defect automatically, but then we also have some sort of a robot arm that takes the defected fruit out at the time of the processing. Most warehouses have something like this, where they have a good visual of the sizing and the color and some defects, but ultimately, we would love to have robots help us, because this is what it used to look like. A lot of people sorting through fruit. And that is and this is all the fruit is about 33 degrees Fahrenheit. So this is a really hard job for everybody. Another area where we need help is accurate cull data. Because most of the time, our cull analysis is based on a 50 fruit sample after storage that does not take into account the maximum amount of culls that would have been possible in storage, far too small data set. It doesn't take into account in orchard or what was left on the tree. And that doesn't really help us make good horticultural decisions. We are using some robots, for example, to stack robots and sometimes impact fruit storage as well. And that is great. That really eliminates some of these really heavy jobs where people really hurt their shoulders and have repetitive motions. Where we really need more help still is to avoid repacks. Most of the repacks happen for one of two reasons. Either it's the wrong package, but most of the time there is decay in the box. And then that becomes very cumbersome. So we need help there. And the last aspect I want to bring up is food safety. We have to remember that most fresh products have no kill steps. So we need to, once pathogens are introduced, they're really difficult to remove, and typically a hurdle approach is used. And so while we can have wish lists for packing lines regarding design and having more sanitary design, really where AI and new technology really can help us is to make it easy to do the right thing, to help us crunch data, to basically help us determine which area has to be cleaned and when, is there a risk and what is the risk, but also to save money and not do something that might not be necessary to do. This is an example of where we're working on a dump tank project, where we're trying to figure out how to model having the chemicals adjusted in the dump tank. So that will happen. With this, I'm going to stop, and I am going to stop sharing. And in order to give this a little bit more of a flavor, I have asked two of our industry members to give us their ideas in terms of what it is that they would really like to see in a packing house. First, I want to call up Rob Blakey. He is with the milled growers, and he will share some of his vision of what he thinks we need going forward, and that would be most helpful in his operation and day-to-day life. Go ahead, Rob.
Hi, everyone. Yeah, thanks for having me. I think just to add some color and the level of complexity to what we have in the tree fruit space, just with we're farming from border to border, north to south, with so many growing districts, so many farms, so many apple varieties, different maturity stages, different storage durations, different storage rooms with different capabilities, and then obviously different customers as well. So it's an incredibly complex supply chain or web that we're trying to manage. So that complexity lends itself well to some artificial intelligence to make better decisions, laying that all out to match supply demand with your packing house in the middle. So improving those efficiencies there, and also catching any mistakes. Most of the time we get it right with expert storage managers, but sometimes fruit do weird things. So having some artificial intelligence to take that quality control data and flag it and say, this is looking like it's going to have some problems. You need to readjust your supply chain to optimize this outcome of fruit, so that we're reducing food waste, reducing those the repacks like Ines was talking about. So yeah, some AI to help with the complexity of logistics and supply chain would be good as well. And a big leap forward is, can we like to grow the fruit, sell the fruit, pack the fruit. Eventually, it would be nice to sell the fruit, grow the fruit, pack the fruit. So really dialing in what retailers need, growing to order, which is very hard with permanent crops, and then sell that fruit. So just getting a lot more nuanced on how we're growing, storing, packing, and getting that fruit into retail would be very beneficial. Having some better decision support tools for making those decisions on when to pick, also very, very important and impactful as you move through the supply chain.
Thank you, Rob. And I have another person, Matt Miles. He works for Allen Brothers, that will also share his ideas.
Hello, can you hear me?
Yes.
Perfect. So yes, thank you for the opportunity to share some things. I think that Rob and Ines have touched on a lot of aspects. I think the part that I would add to that is these are complex problems. There's a lot of data involved. It happens over the buds on one tree happen in the first year. That fruit isn't even harvested until the next year. And sometimes that fruit isn't even sold until the third portion of this, well into the second or the third year. So these are long-term issues that happen, and that ultimately what we're trying to solve for is to give the consumer the best eating experience they can, the highest quality piece of fruit. And so where AI and things like large language models, large image models, machine learning algorithms can help us with is to take these large problems and to break them down and to make them so that we can understand what are the changes we need to do within our operations so that we can provide that quality product. So some of the challenges that we face are not just that it's not always understood what is the techniques and what is artificial intelligence and what does that mean. I really don't like that term because it's not a lot of artificial around it. A lot of very smart folks have put time in to create these things, and that we need to understand how to best use them. The thing that we are seeing at Allen Brothers is just the need for standardization of data, and many of us have years, decades of data. So you think that might be helpful, but when you really get down to trying to solve some of these large problems, you have to break it down and make sure that all the different data sets talk to each other, that you can use them in these analysis techniques. And you might find that when you really start to look at it, you're limited by your shortest amount of most useful data. And there's maybe some things that we haven't even started to collect. So I think the challenges going forward are how do we use these techniques and tools so that we can improve the quality of our product and make it more efficient, which means that we're maximizing the dollars and effort that we put in to create those products.
Thank you very much, Matt and Rob. Back to you, Scott. You're muted, Scott.
I'd be okay.
Scott, so go ahead. Sorry.
Okay. So thanks, Ines and Rob and Matt. It was great to hear that from that amazing fruit expertise so quickly. Next up is Juming Tang from the University of Washington, who will share what's becoming possible in AI-driven food processing.
Thank
Go
you,
ahead.
Scott. Thank you, Washington State Academy of Sciences, for this opportunity. What I'm talking about is more broader as a way from the production to the consumer side. I'm currently chair of industrial and systems engineering at University of Washington. Most of our faculty are doing data science and AI. I'm fortunate to interact with those people, but I see a future opportunity to work with the industry further. But also, I'm adjunct professor with system engineering, Department of Biological System Engineering at the Washington State University, where I worked for 30 years before I joined UW 2024. So I'm both a Husky and Cougar. So a general overview about the food industry, and I'm looking from the consumer side, because if you look at the value of agriculture produce in the U.S. market, we're talking about $2.6 trillion expenditure, and it's about 87% of GDP. So Scott's mentioned about not profitable at the farm gate, but if you really look at the value of a consumer side, it's large, a very large market, and agricultural value only is about 1/5 of the market value. And so a lot of value added is during the productions and processing. So AI can indeed bring, hopefully, the market closer to the farmers, to the rural community. And there may be opportunity for farmers to engage in the value added process. I'm going to talk about a new dietary guidance just come out that may provide some opportunities. So AI used for the operations that in previous speaker talking about sorting and grading, food processing and carting, mostly in the meat industry, and using robots to trim and sorting and reduce the labor cost, and also inventory and storage. And we talk about in the next two speakers talk about supply chain and quality traceabilities. So I just remind people that we do have a good high-tech technology company based in Washington. And one example is Key Technology in Walla Walla. And they produce the best sorting machine based on AI in the whole world. They are doing this, combine the data science with vision systems and to provide a signature of the produce, and then also reject the foreign objects in the system. So this is a latest example of the machine. But also AI has been used in the food industry for formulations. So McCormick 2019 was launched new products based on AI platforms, joint collaboration between IBM and McCormick. The leading person, Dr. Harmon Ferretti, I think Scott met with him. He's the one that leading this effort. He was a professor at Washington State University. So using the AI tools can reduce the iterations in the product development. So those are the three products that come out of the AI. So you can use AI to develop formulas. So imagine that small companies can use AI to develop formula for consumers in the rural community. That really can increase the value of your locally produced products. Automations, and previous speaker talk about in pack houses, but in the food industry, we use a lot of AIs, robots driven AI driven robots in industry. But for workforce education, I think that was the topic that brought up. So the College of Engineering at University of Washington will offer robot certificate and master degree programs for graduate and professionals. We're going to start in the fall 2026. So anybody interested in taking this class, or your employee want to take this class, we're going to provide fundamental robots and also hands-on robot courses on campus of University of Washington. So this is a kind of the summary of AI in food processing market. If you look at the category of a food industry, uses AI, fresh produce, fruits and vegetable, and the convenient product, and then dairy and meat and poultry. Those are the major users, industry using AI. But if you look at the really what's the application of AI, most of the AI is used for quality control and safe compliances, consumer engagement, food sortings, inspection, sorting, and maintenance. So there are about 70,000 companies in the latest survey by Food Safety Magazine that doing AI related research and also services. So you can see the trend that's going to go up in the future. So there are a lot of startup companies working on AI applications, and hopefully some of our own companies going to engage them and find out what the advantage of using them. But AI is also a concern using AI, and here's a report written in August 21, 2025, last year. It's concerned mostly the transparency. The company who uses the AI needs to know how the sensors are used, obtained, and what's the function and how you make a decision based on sensors. Data security and cyber attack is a major concern in food companies when using AI and lost control of the data. And the large language model is actually has been trained for general users, but may not be accurate for food safety and for food applications. So I used the latest large language model, Chat GDP 5.3, couple of days ago. I answered some of the simple questions about food safety, and I didn't give the right answer. So we need to validate those models and develop a specific model that using our own data sets to support the decision making. So that's the challenge. How are you going to provide the data set that can be used by AI? How you validate it, and then you can have the solid, reliable tools for food company to use. And there's a lot of skepticism in the industry about AI in smoke or mirrors. So those are the concern. But challenges in the food industry still remains. Number one is the safety. You can see the number of people get sick, 48 million, 15% of US population get sick, and also the economic losses. Those are the bacteria and viruses that mostly contaminate our product: Listeria, E. coli, Salmonella, and also noroviruses. So we need a good supply chain that control those pathogens before reaching the consumers. Otherwise, the recall can be very, very costly. I just want to bring home this story about one local company in Prasa. I don't want to name that this is a frozen food company that this co-packer, and then their frozen vegetables get into 350 consumer products under 42 separate brands, and then there's another 100 products contain this ingredient from this company, and this major recalls 2026. So the CDC reported this. So yeah, food supply chain, especially related to frozen fresh produce, is a major concern. So we need a more effective detection methods, predictive model for bacteria and for viral pathogens in agricultural produce through the supply chain. Food waste also is a major problem. We're talking about 30%, 35% of food are wasted. even after reaching the market, after so much energy and resources expended. And so you can see that there's a very high value product, meat and poultry, fish, vegetables, and dairy products. So this created major food security and environmental issues. Food waste is the #1 single largest material sent to landfill. It's 57 million tons per year. So EPA just came out last year about guidance that they discourage landfill. They want you to upcycle and recycle the products before you reach the landfill and even digestions, because the micro plastics may create problem for farmland. So we need a smart sensor models to predict and indicate shelf life and through the supply chains. And the next two speakers may address more details about their company or their research into this. So Washington State, we just get a new funds from Amazon to develop an AI-driven platform for management of supply chain for perishable product across the ocean. So we work with Tsukuba University, develop sensors. In particular, we're trying to develop a quality and shelf life indicator that can be attached to the package through the supply chain. And then you use AI apps to translate the information to the cloud, so you can detect where the problem is in the supply chain and how much shelf life is left and how safe it is when you reach the market. So this is the starting point of our project. And we got this is support from Amazon. So #3, this is maybe opportunities, food health, human health. #1, okay, as U.S. is the #1 country that has those kind of obesity kind of issues. You can see the trend on the right-hand side, adults and children's. So the school program has become a very important part to control the obesity in childhood. Is started to see the strong correlation between children's with obesity symptoms when they come to the adults. So this is a study at the University of Washington, a very high-profile study. They surveyed 190 countries, and it's 10-year study that showed that lack of whole grains is one of the major causes of the death and also loss of quality of life and of the high quality lives. You can see that the recommendation is about 25 grams per day of whole grain meals and the low intake of salt. So about a few weeks ago, there's a new guideline come out that emphasizes on the whole grains. But the good news for the farmers is that this is the first time they include red meat and whole fat dairy into the dietary guidelines. So the previous versions, they actually reject this whole fat dairy and also red meat. So this is a very important message. And school program is actually trying to follow this guideline to develop the school meals. The problem with the school meals is that they get only $4.5 return to serve one single meal for lunch. The cost of a meal is about $1.5. A lot of it is labors. And so AI can help them to source those inexpensive agricultural produce and to support the school program. Their managers are struggling getting the cheap products, cheap supplies. So this is something that you can help as an industry. So Washington State University, led by Kevin Murphy, just got a new grant from Washington Research Foundation and Washington Grant Commissions, and the University of Washington is part of that. We are trying to bring whole grain meals to the market, and our first group of target is the school programs. So AI hopefully can help us to formulate a new product based on whole grains. So there's a lot of new tools come out. That I don't know if people see that. And so about last week in a family party, I saw people wearing this glucometers actually, and he showed me the glucometer before dinner and after dinner. So people are very, very conscious about the food they eat, and also On the left is a product produced by one of our department alumni called Wise Labs, based in Kirkland. If you use this balance, give you about 13 different kind of health metrics, including the body mass, fat, and stuff. So people start to be conscious about their own health, and they use these tools to provide information about their health. And that probably going to drive the future ready-to-eat health meals, personalized meals that may create opportunity for farm community to bring the meals directly processed in in urban community and bring to the communities, in urban communities in Seattle. So growing with AI, I like this topic. I like this title. I don't know who created that. But we do need an ecosystem. We need expert work with domain, AI expert work with a domain expert. So I was at one of the top summit of AI, and people work on AI training models. They are not familiar with domain knowledge. Sometimes they ask what's beyond large language models. They are concerned about the next step. How are you going to bring this AI to the production, to the everyday's life, other than language and pictures? So we need to have an ecosystem that bring together domain expert with AI expert. Scott mentioned about data. What's the contribution of domain knowledge expert? We are the one we need to develop a reliable data set and validate expert model and bring the simulation digital twin into the picture. But also we need to work closely with AI expert to provide the platform. So in the future, there will be a lot of agents, and each agent may provide a different kind of support, and the data set can belong to your own company. So your localized AI data set does not need to be on the cloud, but you can use a general LM to bridge those the interface, the users, and then the data set. So this is where I see the opportunity is. Also, I see opportunity working between Washington State University and University of Washington, and thank you for building the bridge for us. Just talk about bridge. This talk is very in line with National Academy of Engineering. And last year in DC, they have this topic, future AI and opportunity and risk. But also they publish bridge magazines. And then next 2028, I will be, me and Dr. Paulson, UC Davis, they ask us to organize an article, a special issue for Bridge about AI for agriculture and food. So we are going to look for writers. We're talking about 12 articles for this. So anybody interested, contact me. So that's it. Thank you very much.
Okay, thank you, Juming. Next, we have Shyam Sablani from Washington State University, and he'll share some cutting-edge research at the intersection of artificial intelligence. Sorry, I'm getting mixed up. No, that's right. He'll share cutting-edge research at the intersection of artificial intelligence, cloud computing, and digital twin strategies in food logistics. Go ahead, Shyam.
All right, you're able to hear me?
So it sounds good.
Okay. Hey, thank you, Scott, for the introduction, and thank you, Washington State Academy of Sciences, for giving me this opportunity. So my talk is going to focus on food supply chain management and how AI can help to reduce the losses and make the supply chain more efficient. So as we know, food supply chain plays a vital role in delivering the food to the consumer. However, there are significant losses, as previous speakers also alluded, especially to temperature-sensitive foods. For example, fresh produce, dairy products, fish, meat, and poultry. Considering there's so much effort is being put by farmers to overcome challenges of climate change, water, labor, this is very important so that we are able to reduce the losses through the supply chain. So we are looking into the pilot projects we call digital twin, which is the combination of AI and Internet of Things to manage the supply chain more efficiently. So digital twin, this word has been alluded in previous webinars as well. It is basically a virtual replica of the real world on a computer based on the collected data. And IoT is basically, GPS, RFID, mobile sensors, etc., which helps collect large amount of real-time data, uh, and which can support the big data analytics and artificial intelligence. And these tools can help enable, these tools can help monitor and analyze the agriculture and food commodities flow from farm to retail stores. And digital twin then eventually can help the inventory management by providing the remaining shelf life of the food product, which is going through from farm to the retail store. Overall, the data which we collect through the digital twin can also contribute to the development of traceability framework, which can also support the food safety, especially in case of the outbreaks when we want to find out or detect where actually problem occurred so that we can have the appropriate action. So this digital twin can also support this kind of a traceability framework. So how does a digital twin will look like for food supply chain? So food supply chain can be from production to the consumer. However, the digital twin, which we are looking into building, uh, is from production up to the retail, because most of the technology which has been developed can be easily integrated and implemented in this digital twin framework from production to the retail. So that requires the implementation of a lot of sensor which can be installed throughout the supply chain with the product. Example, temperature monitoring devices, humidity sensors, vibration monitoring devices, um, gas monitoring, and imaging systems. Now, these sensors can provide the signals which can be then communicated through the devices, for example, RFID, Wi-Fi, Bluetooth, and so on, to the storage systems where it can be analyzed further to predict the status of the product using the AI-based or machine learning-based models. So this is how the digital twin will be implemented or we envision for the food supply chain. For example, at the farm where food is produced and packaged, the sensors, it could be temperature sensor, humidity sensor, and so on, with the microcontrollers can be placed within the package alongside the food. In some cases, the sensor could be invasive. So rather than installing the sensors within the food product, we can design the biophysical model of a fruit which has very similar properties as the real fruit. Uh, and then we monitor the fruit conditions in terms of the temperatures and other parameters throughout the supply chain as it is moving through. And then it can transmit the data in real time to the cloud, where the machine learning and AI-based programs can take this data and combine with the food quality degradation models, and then can estimate the remaining shelf life of the product. Now, this information can be accessed by the inventory managers who are monitoring the supply chain. And then based on the product condition, they can make the decisions. For example, if the truck containing fresh produce is moving from Wenatchee to New York, and there is a transport delays or there is a break in refrigeration system on the truck, and then in those cases, the temperature might go up and that might affect the shelf life of the food product, which is in the truck. Now, at that moment, the inventory manager may decide who is monitoring the supply, that rather than sending this truck to New York, maybe just download the produce there and sell it locally. So this way, they can minimize the food losses. The other benefit of the supply chain is that we know in case where there is a transport delays or there is a climate change or environmental effects are there, we can adjust the temperature setting or humidity level or the flow rate within the transportation and storage that can minimize the quality changes. This way, we can maximize the produce quality. Also, over the time, these digital twins can keep the historical transactional data about the product, transport line, in-transit warehouses where docking and cross-docking is happening, details about the refrigerated trucks, truck drivers, and weather, and so on. Then it can help to anticipate the what kind of a problem could occurring in the supply chain. So we will have end-to-end visibility of the supply chain and also contribute to the framework of traceability. Of course, implementation of any new technology, we have the economic barrier and environmental trade-offs. So in order to implement this digital twin, there is an initial investment and there's a maintenance cost. The typical return of investment timeframe could vary between 1 to 3 years, depending upon how long is the supply chain. From the environmental perspective, digital twin can help reduce the food waste by improving the storage management. But at the same time, of course, this infrastructure can increase the energy demand, and of course, it can produce the electronic waste over the time. So these consideration has to be kept when we are adopting the new technology. Again, like any new technology, there are always risks, challenges, and opportunities, and many of them, these have been mentioned in previous talks as well as in previous webinars. But I'll discuss one and for each category. For example, if we have the poor quality data, they coming from either the produce or it could be coming from the sensor, then it can make the inaccurate prediction of the shelf life. And if it predicts the shelf life, it overestimates the shelf life, and the product goes bad, sooner than expected, then of course this is a challenge. Similarly, in terms of the opportunity, of course, if we implement carefully and accurately, then of course we can optimize the post-harvest logistics. The other uses of digital twins in agriculture, this has been also mentioned in previous webinars, is like you can create the digital field and then see how different crops will grow based on the current soil conditions, nitrogen levels, and predicted weather. And same way, the digital twins are also being piloted for the animal health and animal farming. So yeah, this is the end of my talk. We are working towards building this kind of a digital twin framework in collaboration with University of Washington, as the Juming, Tang in previous talk mentioned. And we are also partnering with the Washington Tree Food Commission and Washington Tree Growers and some of the startup company who are making these sensors and IoT. And together we plan to pilot this project. So thank you.
Thank you, Shyam. Our last panelist is Claire Zoellner from iFoodDS, and she'll round out our panel with an industry perspective on AI and data science and food safety.
Okay, hello everyone. Does this look good?
Looks good.
Okay. Thanks Scott for the introduction. Thanks Melanie and crew for having me. As he mentioned, I'm Claire Zoellner, the Director of Data Science at iFoodDS, a software provider, food safety, quality, and traceability across the supply chain. I am a food scientist by training, with a research and industry background in microbial food safety. So going to bring the perspective specifically where AI is relevant to post-harvest food safety. I think Ines and Juming have provided some great visuals of the environments that produce comes through, right? Not sterile, there's not a kill step. So food safety practices are really important and aimed at minimizing contamination and growth to levels that could cause illness to consumers. And I'd like to start with recognizing the transformation that food safety data capture and surveillance has made over really the last 2 decades or so, um, and how that's laying a foundation for applying tools like AI. And our journey as a software company obviously has somewhat followed this transition from paper-based information and checklists and slower culture-based methods of detecting microorganisms to more digital record keeping, and now even more in recent times, cloud-based rapid data capture and sharing and connectivity and analytics, right? And many organizations are still evolving along this spectrum. And even within your organization, across your operations, you might be at different stages in the digitization journey. But in general, this reflects a trend from isolated systems and kind of delayed visibility and delayed decision making to more real-time awareness across your operations. And at the same time, regulatory agencies in the food safety space, at least, are also undergoing a transformation and encouraging this in the industry. And so, really, the FDA came out with their Food Safety Modernization Act in 2011, and then recently in 2020, their blueprint for a new era of smarter food safety. There are also public health initiatives. The Healthy People 2020 came out 2020, kind of decade-based, 2020 and 2030. And these are really setting blueprints and targets for a common vision that reframes food safety from no longer primarily a regulatory compliance requirement where we're going to check a box and we're going to periodically review it, to something that's more a system level capability that's continuously operating. It's preventive instead of reactive, and values kind of the performance of that system over just rote documentation. And so again, I think this lays the stage for AI and new ways of doing food safety. And we're kind of at the cusp, right? We're at the halfway point through the 2020s and looking at what's the future of smarter food safety. I love the theme of this webinar series as well, growing with AI, and kind of in keeping with that theme, I'll say that food safety specifically is still very much growing into using AI widespread. There was a food safety expert panel convened by the FAO last year that kind of concluded that there are high impact, high feasible use cases, but in general, the digitalization database technologies for food safety, big data, Internet of Things, digital twin, distributed ledger are still between 5 and 15 years away from widespread adoption and realizing this measurable impact. But I do want to disclose, the remainder of this talk, where companies, are piloting things and where there are explorations as they go through developing their AI strategy and roadmaps. And I'm going to bucket these kind of applications and use cases into three main areas I think all food safety professionals, regardless of where you're situated in the supply chain, kind of have to go through. And the first one is risk communication. So whether you're communicating to consumers directly or your supply chain partners or diverse team members in your organization, I think chatbots, the panelists was sharing this in our preparation, chatbots are the low-hanging fruit for what you can, use to tap in into AI. Of course, there are risks, but I think we are seeing how these are helping upskill in soft skill areas and training on continuous improvement. So some examples in particular for translating complex topics to different audiences or large amounts of information is that I've heard organizations using them to practice messaging for difficult conversations, right, around food safety with your suppliers or manufacturers, or to raise the bar on what they should be doing if they're not meeting your criteria, your specifications. Writing food safety plans, that there are tools out there, again, whether they're accurate, they are kind of providing a starting point for writing, HACCP, preventive control or traceability plans, again, to just minimize the time spent on doing those, and maybe to communicate them in a way that's actually, implemented in your facilities, customize those to your operations. And then lastly, identifying relevant regulatory requirements. If you're going into new markets, developing new products, you're likely navigating a web of international regulations or even national regulations here across different organizations. And so just scoping what's relevant to what you're developing or in your operation. I've seen companies using it that way. And then, chatbots can do more than just conversation, right? There's, you see here the video tools, the image-based tools, along with augmented reality. I think there's opportunities to visualize things that typically our employees cannot see, just to reinforce the basics of food safety that we do and why it is to prevent transmission of microbial and chemical contaminants. And I think there's an opportunity a picture says 1,000 words. So to reinforce that with employees and boots on the ground folks. So first one, risk communication. Second one is risk assessment. So a lot of time spent on assessing risks in products, production and handling environments, and the supply chain. We've already heard a bit about this again from previous speakers. And the emphasis here is combining potentially all this sensor data, computer vision, and these algorithms that can process that amount of data to detect and interpret new risks, and potentially quicker in a more feasible manner. And actually, in one market survey that I read, this is the most common area. 60% of AI adoption in food processing and supply chain is focused on real-time quality inspection and contamination detection. And I think previous speakers have shown kind of some of what that technology looks like in an actual line. And it's shifting the traditional batch testing to more continuous and automated sampling, and often sampling that's not destructive. So we no longer need to remove product from the market to do this testing. We can use image or other kind of imaging tools to have a more less invasive approach. Secondly is improving the environmental context around that microbial data. So knowing, what was going on in the environment when we detected contamination, so that we can build models to forecast, okay, this happened, this might lead to contamination. Again, here's where there's a combination of that sensor, real-time monitoring, and microbial contamination data. And then lastly, on this slide, I would be remiss if I didn't talk about food integrity and traceability. We've seen, again, in the previous talks, some innovation around data capture on products, so labeling, RFID, and other 2D barcodes that can capture more data than traditional barcodes. And that's still to come, right? There's still a lot to be done and to be adopted there, but that's a big piece that is going to help improve traceability. But beyond capturing, where a product is at a point in time, we have to kind of translate that to other products in the market or other players in the market that are using that same product. So that's where AI and kind of search capabilities are trying to fill in data gaps along the supply chain and the life cycle of a product, and then also share that information further with the rest of the supply chain. And so again, more opportunities around translating and sharing data to the right players at the right time. all of that will ensure better traceability. And I have this figure here and a paper here kind of showcases in more depth how different types of AI and machine learning are being used in different applications more specifically. So that's risk communication, risk assessment. Last one, and probably the one that's least far along, is risk management, right? So finally, when an event happens or when a risk is detected, taking swift and appropriate action to manage those risks in a cost-effective manner. And so this one is again around supporting or potentially automating decision making with predictive analytics simulation tools. And I want to just point to actually some regulatory models that have come out that I think showcase what this could look like at scale, really based on the amount of products and the amount of data that the FDA has to handle. They developed a couple tools, one for prioritizing certain imported products for more rigorous inspection, and the second, how they're going to take a bunch of traceability data and synthesize that to find convergence in an outbreak. Wrapping up, we're still 5 to 15 years out, and in these areas, you might be thinking, what's the gap? We've heard about some of the risks that have been brought up by the other speakers. So trying to translate some of those risks, again, around trust and bias or regulatory risks, ethical risk, business risks, into opportunities for coordination. First one, we have to focus on data standards. If they don't exist in your area or where needed, we should be defining those. But I think a lot of times there are existing data standards that exist. We just need to adopt those, whether it's in your own operation first and foremost, but then, across the industry and the sector, aligning on those. And then owning the quality of that data, right? These are the inputs to these models. Secondly, the right use cases, right? So we've seen a lot of pilots, but I think they don't scale or they fall off after a pilot phase. I think due to a number of reasons that we could discuss with the panel, but I think bringing together, right, the expert in the technology, the expert in the problem area, and also regulatory and legal might reduce some of the barriers that end up preventing these from actually going to production scale. And then food safety is something that we say is always collaborative, not competitive. And there is a good practice around sharing, what's working, what's not. And that should continue as we refine the use of AI. Availability of training data, I think this is a topic that will come up, right? There is no publicly available large data set around food safety incidents. And so there's an emphasis in data sharing here and getting industry and government to share and put their data together. Lots of challenges there. I think we've heard from one of the industry members that opened up the talk. Historical data might not be relevant, especially if we don't know how the data was collected and when and where and how. So, use of better inclusion exclusion criteria or exploring some of those synthetic data methods like the digital twins to create this data set that can be used to build these models will really help. And then lastly, prospective validation studies. So how do we know these are really working? I think there are good examples of how there's a phased-in approach. And we can compare this to what we're doing today over time and get comfortable with how it's performing or, adjust. And so identifying metrics and kind of iterating in a phased approach, I think will be important to gain trust of these models. I know I'm over time, but just wanted to wrap with a final thought of, food safety 2030. How will we know we've made it? How will we measure progress? What are we aiming for? And again, I'll reference the FDA's new era of smarter food safety that kind of put together their vision of like what food safety, smarter food safety would look like, and perhaps our progress towards some of these could be a gauge of how AI is using to really improve how we implement food safety. So things like scanning a bag of lettuce and knowing both where it came from and if it's tied to an outbreak. There's a few others on here. I won't read through all of these, but then also having targeted rates that we're aiming for foodborne illness. So for example, 11.5 salmonella infections per 100,000 people. So might help us to gauge, whether these are helping get us where we intend to be. And that is what I have. Look forward to the discussion with the panel. Thank you.
Thank you, Claire. Before we open it up, I think I'll try and mention a couple themes that I heard across the panel there. One is that clearly everybody should be making predictions of post-harvest problems and in food safety. As long as we're making predictions, why not use AI and get a better prediction? And that we need domain experts to help us use the type of data we need in our domain and advise on how to standardize it and make high quality data that's useful. The while we're while people are submitting questions into the chat, I think I'll just ask a question to get things started. And my question is, what for each of you, what is the most important data gaps? I mean, Matt mentioned the point that there's data we're not collecting because we don't know about it yet, or we can't collect it, or maybe it's field and we can't trace it into the packing shed, or we can't use it in our supply chain, but you think you'd like to, what are those data that I think that the data of next week or the future or that we can really use?
Yeah, I guess I can start with that. There's, for example, a lot of orchards are tested before harvest over several weeks in terms of how their maturity progresses. But then that data usually stays separate from all the data that is collected in the warehouse, and it never gets connected between warehouse and orchard, but also over time. And then there's often things with like just data interchangeability. Is it taken on warm food or cold food makes a big difference, right? Or is crop load taken into consideration? Or for something like bitter pit, which is like these spots on the apples, they show up as fruit matures. So if your fruit gets sold right away, it probably never showed up, but you still might have a high bitter pit orchard. And if you don't know that, you cannot adjust your management, and next year you might have a really bad surprise. So those are the kind of things, some examples that come right off the top of my head that where we don't have good data.
Yeah, I think Washington Fruit told me that they some days they get 16,000 bins coming into a plant. So, how do you could you even trace that back to what field it came from or what part of the field? Or is it
Yes.
just like I gotta get these bins out. I gotta put these bins somewhere.
For traceability, we can trace where every bin came from. On a bin level, we can do it, but not on a fruit level.
Yeah, I think that's what I was going to add on the traceability side. There are current lots of challenges and investments into what they're calling the TLC source, which is basically where the product originated and what is the data field that we will use to share that information and how can that be standardized across the supply chain anytime that a new location harvests a product or packs a product or creates a new product. So what is that identifier that can be used in a trace back? So TLC source, there's a lot of work being done right now on that data.
Anybody else want to add anything?
So from the food supply chain perspective, if we keep the historical data, where the product is originating and where it's ending in retail store, then that can help to pinpoint where the problem could occur. So as Clara, you were mentioning, when we don't have this data, but I think when we create the digital twin system, then the system would sort of have this input of this data. So this will just manage those data and can help to pinpoint in case there's any recall where the product is coming from, how much temperature abuse has happened, where it exactly happened, where the docking, in a storage warehouse. So yeah, that might help. Yeah.
But I thought the QR code can be used to trace the product where it come from. But of course, individual products be too expensive. We talk about batch products can be transported to different location. Each boxes can have a QR code, is right? You can trace back where it is packed at least.
Yeah, there's definitely an initiative to update barcodes and packaging, but those have to be also scannable. There has to be infrastructure to actually scan those and capture that data. So that's all still, I would say being implemented. And I think there is a hesitancy to invest in the hardware to scan all of those if the industry is going to switch the barcode. So I think there's still some consensus being driven around what is the next generation of barcodes that will carry product information and more information. Um, so it's a little chicken and egg.
Jordan has a question.
Hello. One question that keeps coming up in each of these webinars that I think is relevant still today is the question that Peter Zhu put in the Q&A, and I'm also very interested in this group's answer. The question is, how should we update food and agriculture education, such as curriculum, to prepare students for the AI era? And I'm assuming that students is meant broadly here, K-12 as well as undergrad or grad. So curious what these folks think about that.
I guess I could kick off. We were also talking about this when we were preparing, but yeah, I think this is very important. I mean, not only food and ag, but every professional area is going to need to be more data literate in the future. And I think particularly in food and ag courses, there's already, lots of math and science, and it makes sense to just bridge and collaborate more. In learning these technologies, being comfortable with it, and at least being able to speak, as Juming pointed to the other side. Um, there maybe is debate of whether it's easier to teach, that technology to the food and ag scientists, or easier to teach, food and ag to a tech person. But I think what's exciting is that what I've seen working in the software space is the excitement of computer scientists, data scientists, to be working in a field that is so rewarding. Instead of working in, finance or sale, retail, working in food and ag is fulfilling. And so I think we should really leverage that to, draw that talent and attract that talent to the field and to students. Yeah.
The University of Washington had a few professors working on those farm, like handheld kind of apps that teaches farm community how to grow crops, and very, very preliminary kind of a prototype. But eventually related to food safety, that's a different level of discussions, and that's more sophisticated, and you need data to support it. You don't want to mislead the students about food safety. And even our extension specialist, Language University, we have extension specialists, and there are only a few people really specialized in food safety. But let them have those AI tools first to train other people. I think we are at the starting point of doing that, but I don't think it's been, food safety part has been to the high school or middle school is too early, I guess, at this time.
I think at the university education level, many curriculums within the food science and engineering, they are introducing the AI-based courses or AI-based topics in different coursework. And I think there is sufficient funding, federal funding. I think recently, Juming, the SAS program, Strengthening Agriculture System, it's a $10 million worth each grant. Overall, I think $140 million investment from the USDA and NIFA in this area to introduce, how to teach K-12 students, AI-based, learning.
Yeah,
Yeah.
this is the first year to have this AI education for agriculture schools. Yes, this is the first
Sure.
year, right? It's $2
Yeah.
million maximum.
Yeah.
Yeah, per
I
project.
want to maybe add another wrinkle. We also have continuous education for people that already work in the industry. And oftentimes that also means we have to do it bilingual in English and in Spanish. And I do feel there is also an opportunity to use something like digital twins to actually train people with actual use cases, or give them the opportunity to tour a warehouse or to make decisions. I think this is using AI for training tools. I think this is some that then Extension can use to help train the community. I think that's another aspect that we could consider.
Yeah, I think AI could be a very good training tool. You can develop the videos about how to discourage cross-contamination and what's the general sanitation practices handling food.
And I would say I need to answer Claire's question. I think it is easier to train a horticulturist on AI than the other way around. Most people think it's very easy to grow something, but it's not.
Anthony's got a question. You're muted, Anthony. There you go.
Okay, had my headset thing up. Yeah, my question has to do with data. It came up again and again in this panel. I mean, it's my assertion that AI is at its best when it has a voluminous set of data to work with. More data is always better. That's been proven. We heard that local control might be possible. We heard that availability of training data would be a challenge. We heard that ownership and control would be a challenge. So I guess my question to the panel is, can you imagine a set of systems and incentives that would really allow data sharing to enable all this to thrive?
Claire, probably you have more connection with companies about sharing data.
Yeah, that's why I put that as a challenge. I think this idea of sharing data from the private sector is not very popular. I think forget if it was Scott or someone else who said maybe what data would be shared and what wouldn't, and so proprietary information, or we see a lot of we're okay if you anonymize the data. So I still think data sharing is not necessarily where everyone is going. But I think, Juming, you showed a case where, and you kind of see this with some of the enterprise versions of chatbots and agents where, putting your data into it is not actually training the model. It's not actually leaving, your secure data infrastructure. It's just putting the model close to that data and you can access it. So I think that's more, approachable for companies with, proprietary data or, data security policies. You can use the data to infer a model, but don't use it to train necessarily, or don't make that available to other players, competitors, or other markets. So I don't know if that really answers the question, but I think that's what that's an alternative approach to relying on a shared data ecosystem for development of models as instead, train a model and make that available. But then, how well does that perform on data sets that is never seen before, right?
Yeah, I guess that should be I see that as a trend. You have a general shared data to develop a platform, and then you use some case study to validate it. But eventually, you're going to have your own, I would call it edge AI. So basically, you have a localized computer with your own stored data, and you can call those data for your use, and then you can populate more data as you move along. This is kind of a self-reinforcement learning of the model that can be anchored to your application. So this is where I see is happening. And then they say that a few hundred people at OpenAI, other companies determine what AI application is. But in reality, they're trained a big models, billions of parameters, and your data may not show up in the training. But eventually, you can only use their LM to call upon your data to provide you the interpretation.
Right. So I think there is a space for, companies to build their own in-house tools. You can leverage some of the technology, but you build a specific model for your use case, and you don't need that. You don't need the same scale of data that's being used to develop these foundational models. You can build a high-performant model on, a data set that you've cleaned and, kind of curated for a special use case.
I think that's happening in big companies. They now hire the layoff people from Amazon or Microsoft. So this about a few months ago, we were at AI Institute for Food, UC Davis, and they invited a few companies to join the workshop. And those companies hire people from AI companies and develop their own data. This is more for formula development. And also, Walmart actually recently recruited an AI expert from Amazon to lead the AI team. They have about 300 AI experts within Walmart. So yeah, those large companies building those AI platforms themselves, but the challenge is for small, medium-sized company who do not have the resources to do that. You have to rely on service company to provide the service.
One of the framework for the supply chain is that, any player in the supply chain who is generating the data, they are the owner of the data. But in case of, for example, a issue, for example, food safety, then the different players in the supply chain share some of the data which can help detect this food safety issue. So for example, they may not share trade secret data, but they may share the temperature data of the warehouse, what happens in the particular moment when the product was in their warehouse. So that can help to detect the food safety problem. So you share the data only when it is necessary and only the amount of data which is necessary to pinpoint the problem. Otherwise, you own your own data. Like every player in the supply chain owns their own data. Yeah.
Yeah, I think the context of the problem also changes the data sharing conversation, right? If it's around quality, right? Supply chain partners are already sharing, quality parameters, between a buyer and a supplier, right? Or mediating that through through USDA specifications, and temperature data is being shared across the supply chain. So maybe it's different, yeah, in the context of food spoilage, and visibility of quality throughout the supply chain to improve shelf life. Yeah.
So we were touching on smaller companies for a little bit there, and that's one of the criticisms I hear of AI. They don't have enough data. That I just heard that, and they might not have enough data for their own, and they probably don't have an AI expert. Um, so I'm wondering, Claire, is that what iFoodDS does? Is they help companies that don't have their own resources like that? Is that kind of what you guys do?
Yeah, I mean, we don't build custom models and tools, but we supply applications and platforms for capturing data, making food safety quality decisions, and on the traceability side, yeah, sharing that with your supply chain partners. And I think yeah, where we come in and help, I would say small, medium, all the way to large. Is again there are likely existing systems at all of those companies that are capturing different pieces of data that are important, right? Think of ERP systems and warehouse management systems, and if you're using production lines that capture production data, those are all kind of being captured in different places. But yeah, there are platforms that try to bring that all together to give you that holistic picture of what's going on. And then that's where I think some of the visions around connecting all of that data to paint the full picture, right, in a digital twin, or maybe just in an analytic or predictive, analytic or dashboard. That's kind of an overview of, I think, where we sit. We try to kind of connect those systems together to drive kind of the overlapping safety, quality, traceability viewpoint.
Okay, well, I'm getting the time's up message, so maybe I'll try and recap a little bit from the Q&A. Things that we've heard before, actually, we need to teach AI to our future workforce nowadays. Ines made the point that it doesn't all have to be in college. They can even do this with existing workers through programs like Extension that can come in and work with your companies. Traceability it can be really important data that you already have but can't really use. Also, data sharing is hard, and I think universities should do whatever we can to make public data public for everyone. So with that, I think I'll turn it back over to Melanie.
Yeah, thank you so much, Scott, for hosting, and thanks to all of our speakers for great talks and a really good discussion.